Okay, Matrix, let's do letter arrangements where the letters are repeated in the word. For example, consider the letters of the word mom. Okay, you'll notice that the M's are repeated in that word. In the previous lessons, we had words, like dreams, where, for example, D-R-E-A-M-S, for example, where none of the letters were repeated, but now we're repeating letters. Okay, now have a look at this. How many word arrangements can be made with this word if the repeated letters are treated as different letters? Okay, now, in other words, what I'm going to do is have a look at this. If you take the letters of the word mom, we've got M, O, M. Okay, now I'm going to call the first M 1 and the second M 2. I'm going to treat them as different letters. So in how many ways could we arrange it? We could have M, O, M, or we could go M 2 O M 1. Okay, so we can swap those two around. Another version would be O. We could also have here, if you think about it, O M 1 M 2. Okay, so we could do that. Then we could have O M 2 M 1. Then we could have M 1 M 2 O, or M 2 M 1 O. And there's actually six possible word arrangements that can be made. They don't have to make sense, but it's just the arrangement of the letters in the word. Okay, so there's three different letters, and if you think about it, if you take M-O-M, how many letters are there? There's three different letters. So in fact, if we think of it like we've done in the past, there's three spaces. In how many of those letters were they different? Okay, you've got M1, O, and M2. In how many ways, how many choices do we have for the first position? 3. We could have chosen M1, O, or M2 for that. So let's say we put M2 in there. So we've got M2. Now we're down to 2 possible letters, which would give us 2 there. So we might pick M1 there. And then we're down to 1, which would be O. So if you think about it, in how many ways can we do that? It's 3 factorial, which is 6 ways. Look at this. 1, 2, 3, 4, 5, 6. So if you see it up top there, we've done it in 6 ways. Okay, 6. So in other words, what you're saying is when the letters, if they repeated, so M-O-M, you've got M being repeated. What you do is, if the letters are treated as different, in other words, you're not seeing M, the two M's as the same, but you're seeing them as M1, M2 as 2 different letters, then that would be 3 factorial. It's like any other word. If you take, for example, the word eat, if you look at it, there's 3 different letters. Okay, now in how many ways, how many word arrangements can we do? Well, we've got 3, 2, 1. We could have put E there first, we could have had T there and A. Okay, so if we had E there, there's 3 possible choices for the first position there, and if we chose E, now we're down to 2. Then we chose T, we're down to 2, and A, we're down to 1. So that's again 3 factorial ways, and the letters are all different. Likewise, if you treat in the word M-O-M, if you treat the 2 M's as different, like you would with the word eat, if you treat them as different, then it's 3 factorial. You count the number of letters, there's 3 letters, and you go 3 factorial. 3 times 2 times 1 is 6 ways, and you can see that there are 6 ways. If you look at this, 1, 2, 3, 4, 5, 6, the 6 ways of arranging those letters in the word to create 6 different possibilities there. Okay, now look at number B. It says, how many word arrangements can be made with this word if the repeated letters are treated as identical? Now watch this. This is interesting. So if you've got M, O, M, okay, now you're treating, in other words, you remove those 1s and 2s, and you've got the word mom. But you could have also had M, M, O, or O, M, M. There's only 3 options available if you treat the letters as the same. So in other words, if you take, for example, if you look at this, if you had M1, O, M2, and M2, O, M1, here the letters are treated as different. But if you remove the subscripts, if you remove those little numbers there, now those are the exact same words. So in other words, we're not going to worry about different letters here. We've got them, we're treating them as the same. So there's only basically, if you think about it, there's 3 possible ways of arranging the words if the letters are treated as identical. Now I want to show you something absolutely brilliant. Now watch this. There are 3 letters in the word, okay, mom, okay, and there's 3 possible arrangements if the letters in the word mom are treated as exactly the same. Okay, now another way you can write it just from maths, you can put a 3 there. Now watch this. I'm going to do this. I'm going to write times 2 times 1 on top, but you can't just do that. So on top I'm going to put times 2 times 1, and I'm going to do it at the bottom. Now what actually happens now is that this becomes, if you think about it carefully here, 3 factorial divided by 2 factorial. 3 times 2 times 1 is 3 factorial, and 2 times 1 is 2 factorial. Now have a look at this. If you think about this carefully, I'm going to explain something to you. We've got, if I said to you, if you take the letters of the word mom, and the letters, the repeated letters, so your repeated letters are identical. Okay, they're identical. We treat them as identical, and there are 2 identical letters. Now, if you look at 3, another way of writing 3 is 3 factorial over 2 factorial. Now, this is going to be of interest to us. Now, look at this. If you think about it carefully, in this number 3 factorial over 2 factorial, which is actually still 3, that numerator, the guy on top, represents the total number of letters in the word mom, which happens to be 3, so you go 3 factorial. The 2 at the bottom says very simply that this represents that the fact that the letter M is written twice, okay, is written twice. Okay, so you can see M, there's one letter M, and it's written twice, so you write 2 factorial there. And then if you work that out, you've got 3 factorial, which is 3 times 2 times 1 over 2 factorial, 2 times 1, which actually 3 possible ways that you can arrange the letters in the word mom if the letters are identical. If they're different, then what happens is you're going to go, if it's different, you're going to go right. If the letters are different, it's 3 factorial. Look at A there, 3 factorial. Okay, now let's do another example just to clarify this quickly. Let's take the word difference. Okay, number A. Let's look at the word difference. Well, if you think of difference, let's just write it down and see how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. So there's 10 letters there. Okay. And of those 10, and we're going to treat these as different letters now. So how many possible arrangements can we do with all these letters? 10 factorial. 10 factorial. So in other words, there's 10 letters in the word difference, and we don't worry, the letters are treated as different, so we can arrange them in 10 factorial ways. But in number B, if the letters are treated as identical, now what happens is you've got, if you look at this, you've got 10 letters. Okay, now what are the repeats? We've got, if you look at the F's, there's an F and an F. So the F is repeated twice. So we've got 2 F's there. So there's 2 of those. So this is 2 factorial. Okay, that's repeated in 2 factorial ways there. Okay, you could say 2 factorial. And then we've got what other letters are repeated. Look at this. E, E, and E. So we've got 3 E's there. And this is going to be 3 factorial. In other words, it's the letter E, and it's written 3 times in the word. F is written 2 times or twice in the word. So how do we get the possible arrangements when the letters that are identical or the repeated letters like F and E are treated as identical? Will be the total number 10 factorial divided by, okay, the F's, there's the letter F is repeated, it is written twice, so we can write 2 factorial for F, and then the letter E is written 3 times, so we write 3 factorial. So that is for the F there, and that would be for the E. The E is written 3 times, the F is written twice, so F is 2 factorial at the bottom times 3 factorial for the E's, and 10, that's the total number of letters. And then if you work that out there, it comes to 302,400 ways of arranging the different letters in this word, where the repeated letters are treated as identical.